steady state analysis of AC circuit with pure capacitance. The third quantity is pure capacitance. So now in this case also, if you apply a voltage here V to a capacitor, therefore the voltage across the capacitor is Vc. Therefore here V is equal to the applied voltage V is equal to Vc, and where V is defined as Vm sin omega t, and the current in this one is I. Therefore, let us find the expression for the current. So to find the expression for the current, we know the fundamental relationship between the charge capacitance and voltage, which is equal to Q is equal to CV is a fundamental equation where Q is the charge in a capacitor, right? So this for Q is equal to C into what is V here, instantaneous value, and that is given by Vm sin omega t. Therefore, we have another relation between the charge and the current in a capacitor is given by I is equal to dq by dt. So Q expression already we know. So then if you want I, what you have to do, you take the derivative of this expression. You take the derivative of that, that is I is equal to d by dt of C Vm sin omega t. So when you take the derivative of this equation, C and Vm are constant, therefore you can plot it here like this. And derivative of sin omega t is equal to, what is the derivative of sin omega d by dt of sin omega t is equal to omega into cos omega t. Since you are derivating with respect to time, so omega is also becomes a constant for that. And see here, this is that expression. Therefore, if you, and in this expression, these three things are constants. Vm, omega, and C. Therefore, I rewrite this equation like this: omega C into Vm is therefore as Im, and cos omega t, I write it as in terms of sine as like this. Sin omega t plus pi by 2 is cos omega t. Therefore, if I designate this omega c into Vm as Im, then the current expression would be I is equal to Im sin omega t plus pi by 2. So if you apply a voltage V is equal to Vm sin omega t, then the current in a pure capacitor is I is equal to Im sin omega t plus pi by 2. So what do you mean by that? This plus indicates that if there's a sinusoidal voltage is applied, a current is also a sinusoidal, but with a phase shift. So phase shift here. So what type of phase shift here? It is positive phase shift we got. So a positive phase shift is nothing but leading quantity. Therefore, so positive phase shift we call it as a leading. That means we can say that the current I leads the voltage by an angle 90 degrees. I leads V by 90 degrees. Let us draw the vector diagram of voltage and current in a pure inductance. Right. So since voltage is taken as reference here, see here, this is the voltage we have taken as reference. Right. And this voltage must be either VRMS or Vm. Please keep it in mind always while you are writing. Right. Either you take the magnitude of the phasor is VRMS or Vm. And since I is leading, since the vectors are rotating in counterclockwise direction, voltage ఇక్కడ ఉంటే current lead చేయాలంటే కంపల్సరీగా ఈ ముందర ఉండాలి. So current vector we have drawn with an angle of 90 degrees. So this is the phasor diagram for pure capacitor, right? And the waveforms, voltage waveforms, the voltage waveform is given like this. It starts from 0 and at a 2 pi here. This is half cycle pi and this is full cycle 2 pi. And whereas your current, since it is leading, when voltage is 0, current will already started. Current waveform is already started here. See, look at here. And when voltage becomes maximum, current will become 0 here. అంటే ఒక సైకిల్ కంప్లీట్ అయిపోతుంది. అంటే ఇక్కడికి కరెంట్ మాక్సిమం వస్తుంది. when voltage is 0, current would become maximum. ఎందుకు మీరు ఇందాక ఆ ఎక్స్ప్రెషన్స్ మనకు వచ్చాయి కదా, V is equal to Vm sin omega t is the voltage expression, I is equal to Im sin omega t plus pi by 2 expression. ఇందులో so this instant is referred to omega t is equal to 0 degrees. So now substitute omega t is equal to 0 here and here. Then what you will get? V is equal to 0 you will get, and I you will get as I is equal to, the sin omega t 0 better sin 90. So what we will get is sin 90 is 1, which is equal to Im. That is at omega t is equal to 0 degrees, V is 0 and I is maximum. అదే చూడండి ఇక్కడ. Now V is 0 here, I would become maximum here. The current waveform attains Im. Right. And when omega t is equal to pi by 2, this is the instant where omega t is equal to pi by 2. తీసుకెళ్ళి ఇందులో సబ్స్టిట్యూట్ చేయండి. At omega t is equal to pi by 2, what is V? V is equal to Vm sin pi by 2, which is equal to Vm only. Whereas I is equal to Im sin pi by 2 plus pi by 2. So how much it is? Sin 180, that is equal to 0. అది instant. So this is how the current waveform and voltage waveforms of a pure capacitors are drawn, right? So then a capacitive reactance. So ఇందాక ఆల్రెడీ ఆ ఎక్స్ప్రెషన్ లో మనం IM ని డిఫైన్ చేసాం. IM is equal to Vm into omega c వచ్చింది అక్కడ. So that Vm into omega c, I write it as Im as like this, and this I will write it as Vm by xc to satisfy the Ohm's law. Ohm's law ప్రకారం Im is equal to current is equal to voltage divided by impedance. Therefore, this Xc is the capacitive reactance, where that capacitive reactance Xc is equal to 1 by omega c. What is omega? Omega is 2 pi. So it is given as 2 pi fc. ఇదే చూడండి ఇక్కడ. This is Xc. Right. So therefore, this Xc we call it as capacitive reactance. And the units for this one is, since it is reactance like resistance, therefore ohms. Then coming to the instantaneous power. The instantaneous power in the above circuit can be represented once again P is equal to V into I instantaneous value voltage multiplied by current, where voltage is given by Vm sin omega t and current is given by Im sin omega t plus pi by 2. And ఇందులో ఈ రెండు కాన్స్టెంట్ కాబట్టి పక్కకి తీసుకొచ్చాం sin omega t into cos omega t. So I will write this as sin 2 omega t by 2. అదే రాసాం. Therefore, the instantaneous power what we got is P is equal to Vm Im by 2 sin 2 omega t. So this is also an instantaneous power is also fluctuating in nature with a frequency of double the frequency of the voltage and current, but it has a positive, this is a positive power you have, right? And average power, if you look at that, P is equal to 1 by 2 pi integral 0 to 2 pi Vm Im by 2. So దీనికి ఇంటిగ్రేట్ చేస్తే లిమిట్స్ సబ్స్టిట్యూట్ చేస్తే the average power P average would become 0 here. So therefore, the average power in a pure capacitive circuit is 0, or in other words, the power consumed by the pure capacitance is 0. Therefore, in case of a inductance, pure inductance, in case of a pure capacitance, the average power over a cycle is 0. So 2 pi తీసుకున్నాం కదా, over a cycle is 0. If you look at the waveforms, if you look at the waveform of both voltage, current, and power in a pure capacitance circuit, they represent like this. This is the voltage waveform, and this is the current waveform. This is the power waveform. If you look at the power waveform is completing 2 cycles when the voltage waveform completes the 1 cycle. That means the frequency of the power waveform is double the frequency of the voltage or current. And since the power waveform is positive, instantaneous power wave is a positive quantity. That is why it is starting from positive. చూడండి ఇక్కడ పాజిటివ్ నుంచి స్టార్ట్ అవుతుంది, రైట్? అండ్ కమింగ్ టు ది ఫేజర్ ఆల్జీబ్రా, మనం ఇందాక ప్యూర్ ఇండక్టెన్స్ సర్క్యూట్లో ఎలాగైతే చేసామో వోల్టేజ్ని వీ హ్యావ్ రిప్రజెంటెడ్ ఇట్ ఇన్ ద పోలార్ ఫార్మ్. దిస్ ఈస్ ద పోలార్ ఫార్మ్, this is the rectangular form. So in the rectangular form, the applied voltage, this is the applied voltage. So the applied voltage is represented as like this. Then the current is, we know that the current expression here it is I is equal to Im sin omega t plus 90 degrees or pi by 2. So this trigonometric expression can be represented as a phasor form as I angle 90 degrees, where here the I is once again is RMS. Please keep it in mind. And this can be represented as in the rectangular form as 0 plus angle plus 90 degrees ni మనం plus j కింద రాయొచ్చు అని మనం ఆల్రెడీ j నోటేషన్ చెప్పినప్పుడు చెప్పాను నేను. Plus 90 degrees can be represented as plus j, right? That is why we have represented as 0 plus ji. So then if you want the impedance Z, right, or capacitive reactance Xc, V by I. So V bar by I bar, which is V bar is expressed as V angle 0 degrees divided by I angle 90 degrees. And this magnitude of V by I is the magnitude of Xc, and ఇది 0 ఇది plus 90 ఉంది, పైకి వెళ్తే minus 90 అవుతుంది. So this is Xc angle minus 90 degrees. And this Xc angle minus 90 degrees can be represented in the rectangular form as 0 minus j Xc. This minus j is a representative of angle minus 90 degrees. అది మనం j operator discuss చేసినప్పుడు చెప్పుకున్నాం, right? So this is how the voltage, applied voltage expression in the phasor can be represented. Now let us look at this as another simple example for the pure capacitive circuit here. A 318 microfarads capacitor is connected across at 230 volts. This is the voltage, and the frequency has given as 50 hertz. Find the capacitive reactance అంటే Xc, RMS value of current అంటే capital I, equations for voltage and current అంటే instantaneous voltage and instantaneous current. So what then first we'll find out what is the first bit Xc. So we from the previous slide we have derived that Xc is equal to 1 by 2 pi Fc, wherein F is given as the frequency F is given as 50 hertz, and capacitance C is given as 318 microfarads and 10 to the power of minus 6 farads, right? And you substitute these two quantities here, then you will get Xc as 10 ohms. So once you get the Xc, if you apply the Ohm's law, right, in a pure capacitive circuit, I is equal to V by capacitive reactance, V by Xc. V is already given as V is equal to 230 volts. This is VRMS. All right, as 230 volts, and Xc is given as 10 ohms. Therefore, the current IRMS is equal to 23 amperes. So అది అడిగాడు RMS value of current. Here's the second bit. So we got RMS value of current as 23 amperes. Then equations for V and I. దానికి మనకు కావాల్సింది ఏంటంటే V కేవిటీ ఎక్స్ప్రెషన్ V is equal to Vm sin omega t. Omega is nothing but 2 pi f. So what is 2 pi into f అంటే 50, right? That will be around 314 radians. And what about Vm? Vm కావాలి మనకి. Vm is equal to that relation between Vm and Vrms is root 2 Vrms. Root 2 Vrms is nothing but Vm, and that you have applied here, see, and you got it as 325. అలాగే Im కావాలనుకోండి. Im is equal to root 2 Irms. సేమ్ అదే ఇక్కడ కూడా అప్లై చేసాం. Then we got it as Im as 32.53. Then once you get the Vm and Im, then V is equal to Vm sin omega t is this, and I is equal to Im sin omega t plus pi by 2. So these are the voltage and current expressions in case of pure capacitive circuit. Now